Hello everyone, welcome back to the channel. This is Navneet and today we're gonna learn about NumPy. So before starting off, I would like you to inform that I'm gonna cover full NumPy library. So I'm gonna create a separate playlist for this, and if you want to learn this, you can always follow the playlist. So let's start off with the video. So NumPy is a Python package whose full form is numerical Python. So this is heavily used for mathematical, logical and scientific calculations. NumPy has built-in functions for many mathematical operation, and NumPy's main object is n-dimensional arrays. So why basically we use NumPy arrays? Because it is faster than that of our regular Python lists. So I have already analyzed it. So the result was your NumPy array was at least 10 times faster than that of regular Python lists. And now coming up to the uses of NumPy, we can use NumPy to create n-dimensional arrays and we can solve mathematical problems, equations varying from quadratic equation, linear algebra, whether it is integrals, derivative, limits. So we can solve these kind of problems. So generally I don't use NumPy for solving these kind of problems because we have advanced version of NumPy, that is SciPy, for those things. If time permits, I will also make a playlist of SciPy and we will looking into how to solve these kind of problems using SciPy. So as we have already discussed, NumPy is heavily used for creating arrays, whether it be one-dimensional arrays or multi-dimensional arrays. So we will look into those aspects further in the video. So I think all of you are aware of what MATLAB is. So basically NumPy lies in the same dimensional plane. Today's scientists or researchers are preferring NumPy with any kind of plotting library like Matplotlib or Seaborn to sort of replacement for MATLAB. So learning NumPy is very useful. So being said that, let's start with the dimensions. Let's talk about zero-dimensional entities. These are called as scalar. Let me give you an example of a scalar. So let's start off with a dot. So a dot is basically a zero-dimensional entity because it doesn't have any length, width, height or depth. So it doesn't have any of these properties. So this is basically a zero-dimensional entity. So scalar is a zero-dimensional value and contains one value only. That's why it is called as zero-dimensional. So in NumPy, a float 32 or a float 64 number is a scalar. So what we will be doing is we will be creating a zero-dimensional NumPy array and we will analyze it. So there is a function in NumPy that is ndim, so which helps us to find out the dimension of whatever the array we are defining. So now let us define a zero-dimensional array. So how we can create a zero-dimensional array? So let me take x is equal to np.array. Then as the definition suggests, we have to take one number. Let's let the number be 45, right? Let me execute it. You can execute it from here or you can just press Ctrl and enter to execute it. So then after I will print x. Now you can see this is an array having only one entity. So if I'll do the ndim of x, then I will get 0. So this is a zero-dimensional array. Prior doing to that, I forgot one thing. So I have already installed NumPy and imported it. So for, let's say, if you have not imported it, so what you can do is you can just do, if you're using a Jupyter, you have to put exclamatory symbol before you are doing the pip install. So pip install NumPy, then just execute this. So here I have already NumPy installed in my environment. That's why it's saying that requirement is already satisfied. Now I have to import it. So let's do that. Import NumPy as np. Now because we're using here np, so I don't think I have somewhere I have already imported it, so that's why it's running. But if you are not doing like this, it will be throwing you an error. So np is not defined. So you have to import NumPy as np, then after we can proceed with the code. Now let us move towards one-dimensional array and how to create a 1D array using NumPy. So first of all, one-dimensional arrays are also called as vectors. Now what is a vector? Vector quantities are those physical quantities which are characterized by both magnitude and direction. So in this you will be having, let me take the same x is equal to np.array. Then what we'll be doing over here is we will pass a list of numbers. So let it be 23, 43, 67, 42, right? And we will execute it. Now if I'll print x over here, you can see this is a list of numbers. Let us do ndim over here. So now you can see it has one dimension. This is like your Python list only. You can access these elements of the array same by doing how we used to do indexing in your list. So let us try that also. So if I'll print the 0th index of x, then I will get 23. And if I'll do, let's say if I'm accessing the second, or let's say I'm doing x of 2, I should get 67 over here, right? So this is like your Python list only. You can access the elements in the same manner. So let's move forward to 2D array or your matrix. This is the most important part. So 2D arrays are also called as matrix. Matrix has 2 axis rows and columns. We also call it as array of vectors because let me define a 2D array and you will understand why the definition is like that. np.array. So what we will do over here is as the definition suggests, it is array of vectors. So this is a vector, right? So I'll create, let's say 3 vectors inside this one. So 1, 2. Right. So this is the vector. This is the second vector. This is the third vector. So that is why it is called array of vectors. So let me run this. Okay, so I have now it should be fine. Yeah. So if I'll print x over here, you can see this, right? And this is a matrix. These are the rows and these are the columns, right? Now just do ndim. You can see this is the 2-dimensional array or a matrix. And in similar way we can create a 3-dimensional array. So basically 3 or more dimensional array are called as tensors. So there is this Google's deep learning library named TensorFlow. So that tensor they got from here. Just a fun fact. So let us create a 3-dimensional array. X is equal to, let us take 1, 2, then 3, 4. Sorry, I have to close the bracket over here. One more. Then I'll do 5, 6, 7, 8. Again I'll cover it with the square braces, and then after this final square braces will be here. Right, so this is basically, oh sorry, I have forgot the np. And let me execute it. So now you can see, right, this is the 3D array. For confirmation I'll do ndim. So now you can see this is a 3-dimensional array. So in this video we have learned about how to create 0-dimensional array, 1-dimensional array, 2-dimensional array, and a 3-dimensional array. And we have also explored the ndim property. So like ndim, we have so many functionalities that we will cover in the next video. So this is it for the video. I hope all of you got how to create these n-dimensional arrays and how to check their dimension. So being said that, let's end the video over here. Thank you very much for watching. Do like, share and subscribe. This is Navneet signing off.